All right, guys, we are ready to start Envision Lesson 1-3. You guys did an awesome job yesterday putting things together to solve word problems. So we are going to do something a little bit different today. We're going to solve problems with both addends unknown, which is a little bit tricky, and we're going to kind of figure that out. We're going to try to find the missing addends by breaking apart some different numbers. So our solve and share is a little bit different today. It says, show how you could place the pencils in the two cups, and then we're going to make an equation. So this, you could do it several ways. So we know we have 5 pencils, and so what we're going to do is we're just going to choose to move some of the pencils in each cup. So maybe I want to put 2 pencils in here, and then 1, 2, 3 pencils in here. Okay, I could do it a different way. I could have done 1 and 4. I could put 5 in one and 0 in the other, but we are just trying to figure out how we could break it apart, okay? So I know that 5 equals if I have 2 in one cup and 3 in the other. And so real quick, we're gonna watch a little video that's gonna help kind of help us understand that concept, okay? All right, here we go.
How many penguins do you see?
So let's think about that. Let's see how many penguins. I have 1, 2, 3, 4, 5, 6, 7. And if I didn't want to count, I could say, you know what? I see one kind of curved line of 4 and one little curved line of 3, and I know 4 plus 3 equals 7.
There are 7 penguins.
Some penguins can go inside the cave and some can go outside the cave.
How many penguins are inside the cave?
So how many did she move inside the cave? That's right, 4.
There are 4 penguins inside the cave. How many penguins are outside the cave?
Select your answer.
How many are there? 3, very good.
There are 3 penguins outside the cave. You can write an equation to show the whole and the parts. What does the number 7 mean in the equation? It is the whole. What do the numbers 3 and 4 mean in the equation? They are the parts. Here is another way to show the 7 penguins. It has different parts, or groups of penguins, but has the same whole, or total number of penguins.
Okay, so we're going to try that real quick. All right, so we're going to drag some penguins inside and outside of the cave. So maybe I want 2 penguins to be inside the cave, and then I want the rest of the penguins to be outside. So we just keep dragging them till we put all 7 in there. And so this way it says I have 5, a group of 5 and a group of 2, and that equals 7. I could move one of my penguins from the cave over here, and now I have a group of 6 and a group of 1, which equals 7. So my parts changed, but my whole number didn't change. I'm just changing the way that I got there.
Now you know how to use different parts to show the same whole.
All right, so we're going to get back to our workbook. All right, so in our workbook, we just went ahead and flipped the page, and you can see up here at the top, that was just the video that we watched, that problem where we saw how we could put different parts inside the cave with the penguins. And so we're going to go at the bottom and we're going to practice that real quick. So our sentence says, there are 5 penguins in all. How many are inside and outside of the cave? So what we're going to get to do is we're going to get to pick how we want to do that. Like there's not a set answer that you have to do. You get to pick which parts are in there. So this one they kind of already told us. they said that there's 3. So I have 1, 2, 3 in one part and 2 on the outside to make 5. But the next one, we're going to see how we want to do it. Okay, this one says we have 8 penguins in all. And 8 is one of those numbers that I know about from doubles because I know that 4 plus 4 equals 8. So I could choose to put 4 penguins inside. I'm just going to draw lines, and 4 penguins outside. And then I would say I have 8 with 4 inside the cave and 4 outside. Now, I don't have to do it that way. I could have moved 2 more inside, and then I would have inside and 2 outside. I could have moved all of them inside and have none outside, and my problem would have been 8 plus 0. So there's so many different ways. It's kind of like when we do our number talks, all the different ways to make a number. You could have done a lot of different things on that one. Right here it says, what are 2 different ways that 4 penguins could be inside or outside of the cave? So it wants us to think about that. So the number 4, how can I break apart the number 4? That's right. The first thing that comes to mind is 2 plus 2. We could have 2 inside and 2 outside, and that would equal 4. What else could I do? That's right. I could do 1 inside or 1 outside, and then I would need to have 3 inside or outside, depending on how I wanted to put them. And we could go through and we could say, well, it could be 1 plus 3, 3 plus 1, 4 plus 0. There are so many different ways that you could do that. So you're going to have a little bit more freedom to where you can really think about it in these problems. All right, let's look. Oh, these are spiders. It says there are 9 spiders in all. Okay, so I have 9. So I get to choose how many I put. And I'm just going to do the little dot since the spider is round. So I'm going to say, well, let's just put 4 outside. So I'm at 4, but I need to get to 9. So I could say, okay, 4, 5, 6, 7, 8, 9. So I have 9 spiders in all. Inside my cave, I have 1, 2, 3, 4, 5, because one of my parts is 5. Outside my cave, I have 1, 2, 3, 4. So my problem would be 9 equals 5 plus 4. All right, let's try another one. This time I'm going to have 8. So I might just play and say, well, I only want to put 2 inside the cave. So now I still have to get to 8. So I have 2. So 3, 4, 5, 6, 7, 8. And I can always go back and count and make sure that I have 8 in all. So I've got 8 spiders in all. How many do I have inside? 2. Very good. And then how many do I have outside? 1, 2, 3, 4, 5, 6. Very good. So my parts of this problem are 2. I have a part of 2 and a part of 6, which makes that whole number 8. Very good. All right, I have 5 spiders in all. I can go ahead and put that by my total. And then what I need to do is I need to figure out how many do I want inside and how many do I want outside. Well, I just want 1 inside. Most of them are outside. So I could say 1, 2, 3, 4, 5. So if I do it that way, how many do I have inside? 1. Very good. How many do I have outside? 4. Good job. So I know 5 equals 1 plus 4. Now, could I have thought of different numbers to do? Exactly. I could have moved 1 more inside and it would have been 2 or 3. I could have moved all of them inside and it would have been 5 plus 0. So it is up to you to choose because there's many different ways that we can make our numbers. Okay. All right. So there are 7 spiders in all. I want to put 3 inside. So I have 3 inside. Now I have to get to 7. So how many more would I need to add? Let's see if you're right. 3, 4, 5, 6, 7. If you said 4, give yourself a big pat on the back because you are exactly correct. So I had 7 in all. One of my parts is 3 and my other part is 4. Very good. So there are lots of different ways you could have done that problem. All right, we're going to go ahead and flip to the next page. Let's see. Oh, math and science. It says there are 8 monkeys. Some are parents and some are babies. How many of each could there be? Show 2 different ways. So we get to think of 2 different answers. So let's think about this. How can I break apart 8? Well, 8 has a double, doesn't it? I know that just by knowing, because I know that to make 8, I can do 4 and 4. And then now that I have 4 and 4 there, I can think of, well, I can change that number just a little bit. So if I take one of the parents away and only have 3 parents, then that means that I need to add 1 more to the babies. And if this was 4, then it would need to be 1 more would be 5. Very good. You could also say, well, maybe I want 1 parent and 7 babies. So there are different ways to do that problem, all the different things we could think of. On this one, it says Krista takes 2 photos, then she takes 5 more. How many does she take in all? So when we say in all, what are we doing? We are adding those together. So our first part is 2. And then it says she takes 5 more. So 1 part of 2, then 1 part of 5, and then we need to figure out how much that is in all. So if I've got 1, 2, and then I add 1, 2, 3, 4, 5 to it, I would have 5, 6, 7 in all. So she did 7 photos in. All right, so we're going to move on to our assessment. Jess sees 9 birds. Some are flying and some are sitting. Match the number of birds flying with the number that Jess could have seen. Okay, so if she sees 9 in all, that means the flying and in the tree would have to equal 9. So the first thing says 7 and 3. Does 7 and 3 equal 9? Let's see, 7, 8, 9, 10. So it can't be that. It can't be 7 and 3. 7 and how many? 7, 8, 9. I would need to see 2 in the tree. So I'm going to match it down to 7 and 2 because we're trying to make 9. Now this says 8 flying. Well, 8's really close to 9, isn't it? So if I have 8, how many more would need to be there? 1 more. So I'm going to match it to the 1. Very good. All right, and then 5. 5, 6, 7, 8, 9. I would need to have 4 more in the tree to equal 9. And so that means 6 would be matched with 3. Let's check though. 6, 7, 8, 9. Good job. All right, what you guys are going to do next is you guys are going to get to be able to do your work in your workbook, your practice. There's only a couple problems to do, okay? And then you're going to send it to me on Seesaw. But as we end, I wanted to kind of give you something to do, and so we're going to get to see a little song real quick.
Missing add-ins, finding a missing part. What is a missing part? This is a part-whole model. The top shows the whole, or the total. The bottom shows the 2 parts that add together to make the whole. So in this problem, it shows that we have 4 plus something equals 10. Here's a word problem that matches. I got 10 balloons at the fair. 4 of the balloons were green, the rest were red. So how many were red? I'm going to draw 10 circles to represent the 10 that I know I have in all. Now, I know that 4 were green, so I'm going to draw 4 green balloons. The rest were red, so I'm going to fill in the rest with red balloons. So do you know what the missing part is? I can add to solve this problem. 4 green balloons plus 6 red balloons equals 10 balloons in all. Or I can subtract 10 balloons in all minus the 4 green balloons equals 6 red balloons. So the missing part was 6. Here's one you can try on your own. My little sister got 3 pink balloons at the fair. Then she got some more yellow balloons. Now she has 5 balloons in all. How many are yellow? So what is the whole? 5. We know that there are 5 in all. And what part do we know? We know that 3 of the balloons are pink. We need to figure out how many are yellow. Do you know the answer? Let's see. I know she has 5 balloons. I know 3 are pink. So 3 plus something equals 5. Or 5 minus 3 equals something. What is it? Did you say 2? If so, you're right. So let's review. If you have a problem where you know the whole, you know a part, and you need to figure out the missing part, you can add to find the answer by counting up. Or you can take the whole, subtract the part that you know, and you'll end up with the missing part. Great job! Keep practicing these problems and you'll be a missing part expert in no time.